So I'm ready to go.
Yes, go for it.
Sorry about that. I'm just standing here. Good morning. Welcome to the TridiumTalk. We're going to kind of explore brick on what it means inside the Niagara, what it means as an ontology. We're going to kind of look at it in a high level way because if we explore all the intricacies of brick, I could probably be here for a couple hours. So we don't want that. We want to give you a little taste of what brick's about. I am joined with Tim Ureta. He's going to be answering questions and jumping in if I veer too far off the pathway. But what I want you to see out of this session is to see how to identify data, see the ability Niagara brings to tagging that data, and see how rewarding it can be. So this is kind of my marketing speak, but it will have context of what ontologies are. What is tagging data, and why is brick something that's the market has out there? All right, so I'm going to kind of give you an overview of all of those components. Keep in mind that Niagara is ever evolving. So when tagging came out, brick was not invented. We had Haystack, and you look at Haystack 4 on how they looked at how they needed to get more details into understanding what that data is. We ever evolve in defense, cyber defense, in certifications, in cloud connectivity. Niagara is a cycle that keeps improving and adding more functionality as the marketplace dictates. 4.14 is the magic number on when brick was included. So that is launched. You'll see that out of all the things, we have a lot of HTML visualizations, which is great for Niagara Cloud's remote. But we're going to concentrate on brick, on how that looks on the tagging database. So this is just kind of a real quick overview. So the first thing we're going to try to do is, how do we identify what this data is, right? How do I classify it? How do I recognize it? How do I describe it so that somebody else will understand what that means? So if we look at 72, that's all we look at. How do you know what that is, right? And I think some of you have already seen how I talk about this, right? Is it the sum of 13, 17, 19, 23? Or is it a measure object in the sky? Is it the number of an angle, an exterior angle of a pentagon measures 72 degrees or each? Is it a U.S. Navy carrier? You get the point, right? Is it 18 holes of golf? We don't know. You and I might know if I'm looking at a thermostat that it's 72 degrees, but a computer would have no idea what 72 is, right? And it doesn't have that context. So part of what these ontologies are is to help a machine understand what's coming at it, because our data could go in various different places. So you and I might know it as room temperature in Fahrenheit. If you're watching this overseas, yes, I understand that that's Fahrenheit, and you'd probably be dead if it was Celsius, but you get the idea of how this works. Now, tagging is nothing new in the industry. If you look at how we keep track of cattle, they put tags on the ears, on vaccinations, on what group that was in. We even gotten high tech with radio. With the penguins, they're tagging them and monitoring their progress as they. So it's not that far out of stretch that we should be able to tag our data, right? And so it all comes down to this ability. What is the skill set? What is the competence I need to be able to understand how to identify that data and the ability to tag it? So in the way I like to do things, we're going to look at this as like cooking. And just like a cooking show, I have some ingredients, I have a tool to whip up those ingredients, and then of course I'll be like the cooking show where I have the final baked product to show you. So using those analogies, let's look at some of these ways of identifying certain components, right? So if I have a building, I want to be able to identify that building, right? A tag is going to help me identify it. It's going to help me identify a floor or a space. It's going to help me identify a piece of equipment. So tags think of them as just clipping on something that says, yep, this is a little more information like of you, like an ID, like that VAV, things of that nature. So I also will, at the end, after I give the demo, give you a little bit about what tag rules are, because I always hear, tagging can be quite intensive. We're getting to a point where that might go away, but right now it still requires us to take effort. But we do have rules that actually, if I take the effort and create a rule instead of actually direct tagging, it actually can essentially automate, what is the word I'm looking for? Automate that process so that I wouldn't have to think through it again. But tag rules are a little more complicated to do because you really have to think through what you're looking for. It can kind of be like a challenge with a puzzle, but it's extremely valuable if you can take that effort to create a rule. And we'll show you some of those that you can do. So in Niagara, we have had a tag dictionary since Niagara 4. We actually use it internal. So anytime you would look at like n:\name, that's a tag. And so we imply a lot. And you're going to learn a little bit about direct tags and implied tags because both of those are quite useful. So we have a way of putting different ontologies into Niagara. So typically you would see a haystack. We then added haystack 4 and 4.13. Now we're adding brick in 4.14. And that gives you a series of marker tags, as well as relationships, as well as grouping tags together, and of course these rules. And then we have the ability to use those tags in many different places within Niagara. So I can search using tags, I can use equal calls during tags, I can use tags in bindings now in PX pages. And I'm going to demonstrate hierarchies because hierarchies are one of the hardest things I can get my head around. But when I start to use these relationships and these tags, it makes it easy. It's actually something I can remember and not forget. And then, of course, templates. Templates will be, I'll kind of just say at the end, when you do this once, if you take a device, tag it all up, make a template of that device, and then you won't have to do it again. You can just apply that device template. So lots of tools in the kitchen here on what we're going to use to do the ingredients. The other thing that we've done is we've made the tag, so it's just like ever evolving protocols, right? Those ontologies change, and they change quickly because they're accommodating. And I'll show you, like Brick had the ability to identify furniture, and then somebody pretty much told them we will never identify furniture inside of a building, so they deprecate it, they remove it. So we need to be able to have the ability within our tag dictionary to get to those newer updates quicker. So what you'll find is with the haystack 4 and with the brick, we actually allow you to import the JSON file, which is the latest standard. So instead of waiting for us to add it to Niagara, you can actually go get the actual JSON file from those sites and then upload it into the tag dictionary so that you're using the latest ontology from those different providers. So that's a big change. Usually you wait. Now we know what we can't wait, and we need to be able to pull those up. And then, of course, you can create your own tag dictionary that applies tags from other dictionaries. So 4.14, we are supporting, or we've derived from the 1.3 standard. So there's about 486 tags, 1,100 some groups, not 11, yeah, 1,137 groups and 16 relations. And I'll show you these relations because these relations, you have to kind of think through and understand them. And then 4.15, we're actually moving up to the next rev of 1.4. This is a ever evolving process. So as we learn more about Brick and we add functionality, we'll add those to our tag dictionary. But it's one of these things where this is pretty new to the market. I hear people ask for Brick, but I haven't seen an install base of that. I see more haystack. So just be aware that as you get feedback on how you're using Brick inside of Niagara, don't hesitate to share that with the community and us, because those are things that we want to hear. So what is Brick? In fancy terms, if I had to put something on the slide and I grabbed it from their website, it's an ontology-based metadata schema that captures the entities and relationships necessary to effectively represent a building and its subsystems. What the heck does that mean, right? Well, it all comes down to is it is a way to describe something, a building, in machine readable format. So tags can benefit us as end users in searching for things. That's a huge thing. It can help you as an SI make hierarchies, but the end goal is that if I have a data stream of data and a machine is looking at it, it needs to understand context. And Niagara has a lot of context, but we need to be able to map some of that context so that a machine, if it finds a point, it can understand where it's coming from, who is it connected to. And this is what these ontologies are all about. It's how to, if I'm given a point, I can figure out where it came from. And I'll talk about that. So the concept, right, and this, all of this information is right from the Brick site, which I have a URL for you to see. So it's one of these things where if you're going to get into applying Brick, it's in your best interest to go visit that site and to kind of read through it. I'm giving you the high level view just to get you understanding what Brick is all about and why people would be asking for it. But again, here's the concept. I have an air handler unit, and inside of Brick, there are these relationships that says, hey, this air handler feeds VAV 2 through 4. What's also cool is if I have a relationship that says feeds, they also have an inverse relationship that says fed by. And this will start to clarify why this is kind of important when you start to map things out for a machine to look at it. But this just gives you a quick, I always go back to this because it helps me understand how these relationships and how these identities work. Brick is based, so one of the things that, if you look at like, and I don't want to, name drop these large social media companies, right? And they have all of these contacts in there, who you're friends with and whatever. There is no way that they could create a sequence, a sequential database, a SQL database, or anything like that because of the scale. Because those databases rely on columns, and then they have to relate those columns to other columns. And as soon as you get this mass amount of data, it starts to break down on scalability, and there's just no way that they can use that. So there's this concept of a graph database. In fact, we actually had to apply a graph database inside of Niagara for the system indexer for the security dashboard, right? So when you look at the system database, it's actually a graph database, because as we acquire all this data, we needed to put it into a format that allows us to quickly ingest that. And then the security dashboard now takes advantage of that, which is pretty cool as we go and pull up all this other data downstream. So this is all about, you got an object or this node, and then you have something that relates back to the next node. So if I go to any one of those nodes, I can backtrack in any different direction to figure out where it comes from. So that's kind of, in layman's term, what we need to do, so that when the machine understands, if it looks at one particular thing, it understands where it can find where it came from, what it's fed by. So again, I highly recommend the website. It breaks that down into paragraphs to kind of explain those different things. I'm giving you the high level thing. Now, Brick has relationships, and that's where a lot of the functionality of Brick comes in. And this is where I'll kind of demonstrate how we set these relationships inside of Niagara. But it's actually pretty cool. When I created a hierarchy, I was all excited talking to the engineers this week, and I'm like, wow, I can kind of remember that, if I'm looking for something, I can say, does it have a part, right? Or does it have a point associated with it? These are relationships that if I put in place, make finding things or making building hierarchies pretty good. But it also, and I'll show you in a mind map tool I use, explains why we're doing it for the machine, right? We need to let the machine be able to go down that graph and understand who's connected to who. All right, so you'll see this again in my my mind map. It's all about setting these up. Keep in mind that if I have a relationship has point, we automatically do the inverse relationship. So I don't have to think doing both sets. I could just do one or the other, and the opposite will take effect all automatically for me. For those that have to know, this is what it looks like in a file, right? If I ingest a model that has brick, this is what the machine is able to read. And so you'll see that there's a VAV, it has a set, a sensor or things of that nature, and it maps back to the set point. And that's how the machine looks at it. I look at that and I don't see it, but the machine does, trust me. So, but that's just there for throwing it on the table of what we're actually doing. And there's a whole standard of RDF on how that file is done. So there's lots of standard organizations working with trying to make a unified way of doing an ontology. Now, when Brick was first introduced, Haystack was the only ontology out there that was kind of widely used. Haystack 4 was introduced to do more of what we see on what Brick was trying to achieve. So these actually work hand in hand, but you need to understand that they're attacking the same problem. So Haystack 4 has the ability for groups and relationships, and Brick does the same thing, but it's all about how to make something that a machine can understand the context of who you belong to, right? And who did I come from, and how do I work within that model? So things that you're going to need to kind of bring up on the screen when you're working through this, and this is just gives me context so that as I'm learning this, I can kind of rely back on that. But there's an ontology, brick schema.org, that has a little tool that lets me walk through the different things that let me explore it before I start tagging. And then I'm going to show you how Niagara helps you do that as well. Project Haystack has the same thing. So this is looking at a VAV, and you'll see all this stuff like entity, equipment, air input, liquid, gas, all these things that we want to apply, but they're tedious, so that's done in rules. And I'll show you how that works too. So there's lots of thought that goes into how these things work. And then again, who's a child of what, and essentially Brick, children are in for, and then part of, and feeds are different into Brick, but they do the same things. So how do I do all this in Niagara, right? And so this is all about what I'm going to do here is let's go shopping for tags. And what tool do I need? So I usually have those pages open so that I understand the context. I'm going to use the HTML tag manager as my storefront. Okay. And if you don't, and I know that, I am a creature of habit. So I've been editing tags through that dialog box that lets me only look at one point at a time. Once you see this HTML version and try it out, it actually, I ditch it. The only time I do that tag is if I want to look at something real quick and I don't look back. So in this, you'll see how powerful it can be. And the search is much better than it is in the typical single point tagging dialog box. So the goal here is with this, it allows me to look at things, lots of things, not just one. So the old way, I had to only look at the tags for that point, and I could never see direct and implied at the same time. So here we have a window on the left where I can put as many points in there and look at them all together and look at them individually. So this changed the workflow really good. The other thing they added was a nice way of doing searches. And what I'll show you in this is that doing VAV is going to show me direct tags, but there are group tags that are much more powerful than just adding one single tag. And a group tag will imply other things. And that's where I want you to get the idea of that. And that is that think through the groups first before you start putting individual marker tags. And again, I'll show you why, because it's all about implying other things. So in this example, I actually added the haystack 4 air circuit, which then goes and applies all these other things like it's a piece of equipment, it's an air terminal unit, it's in parallel, and it's an entity, it's ID. All of that is because I applied a group tag. And that's where some of the power is. If you can find a group that's associated with your piece of equipment, it's much, much less work. And both Brick and Haystack 4 build out these groups so that it makes your life much easier. So I use this to kind of shop through what I'm going to do and apply tags. Once I apply those tags to the points, then we can start to do other things. All right. So I'm going to show you in, again, kind of like in pseudo code here, in that, all right, I have a building. I used to put the haystack site on there, and then I would put haystack geo tags for where it is in an address. And why that might be important and why I still do that, right, is because a machine might want to know that that is a location, but what's its address? And these are great ways of, looking for things in certain zip codes and certain things. So again, I think of it as what the machine might need to do and what I would want to actually search for things. Floor space, here's a zone, and it inherits these. So I don't have to apply those. Let's look at an AHU real quick. And again, I'm using Haystack because these slides were already done. I'm going to show you Brick, fan meter. The goal is look for the group first, and then it will apply. Okay. So let's take one more, and that's going to look at a chiller. So if in Brick, and I'll show you what BK means, and those were called a namespace. But if I want to start to, and we're going to do this in the demo, if I want to start identifying the chiller, I need to mark it as that piece of equipment is a chiller. I usually will mark it on what it is in water. Haystack 4 does that for you, depending on what you do. But once I identify that it's a chiller, it automatically says, okay, it's a piece of equipment. Since it's water, it's a liquid and it's a fluid. Those things I don't really care about, but some machine might. It might understand that I need to understand pressures, water pressure, or things of that nature. So that's why these are important to inherit, but I don't, as the person in tagging, I don't want to really look at it. So here, there's a group that says, hey, this is a chilled water temperature sensor. So if I apply that to the point, look what I get. I get fluid, I get liquid, I get water, I get temperature, I get chilled, I get it's a point, and it's entering. So those are all important things. And why would something in a machine want to understand if it's entering? Well, that's the beginning of the loop, right? So it's going to enter, and then it's going to chill it, and then it's going to supply it to something, right? Or return it to something, or no, supply it to something. Phew. And I need to understand that because I need to see if the chiller is working correctly, right? A temperature before and a temperature after. Here's a loop, right? Differential pressure set point. I can pull that up on a group, and it goes up and it adds a set point. It adds a loop, temperature, water. So you see the thing here? I apply one group tag and I don't have to worry about any of the others. Those are just automatically applied or implied. Okay. So that's when I first started out tagging, I would do those individual things. Yes, that's tedious and that is a pain, and it's hard to keep up with if it changes. With a group, the group can change and it will just imply the next set. So anything out of this, think group and apply that accordingly. So that's direct tagging a point to understand what it is, give it context, and then inherits a bunch of other stuff that the standard wants. Relationships are very important. And so this was one of the things that at first I didn't do. I didn't understand how the relationships work. But now that I've looked through these ontologies, I realize relationships are extremely powerful. And I'll show you how that works with these ontologies. So with that, I'm going to jump into, so I'm going to do two things. I'm going to do the demo where I have Workbench open, and you'll see the product here that's been baked as we mix the ingredients. And then I have a program I use that lets me kind of explain this easier. I had 10 slides that I killed this morning because it's just hard to do in PowerPoint. So this will be a lot easier to explain. So I'm going to jump into this tool here. So think of relationships as a map. So in my first example that we'll jump into Workbench, I'm just going to start super simple. I have a chiller and it has a bunch of points. Okay. And so those points are the pump speed, the return temp. And so what I'm going to do is I'm going to set the relationship, and you can do it two different ways. I don't care how you do it, but I'll show you how to do it. But what I want to do is I want to say that this chiller has points, and then I'm going to have these points highlighted when I actually link that together with the relation. And then I'm just going to point to which one I want it to be, and it will put those relations in place. So I can start here and say, link mark the chiller and say, these are all this chiller has points, or I could highlight the points and say, it's a point of the chiller, right? So it all depends on how you want to do it, but I'll show you that. We're going to then get into a little more detailed one where I create a bunch of folders just to kind of walk through this. But let's say I have a campus, and this is a supervisor, and this is going to show you some of the power of how it's almost like a map of how to get to one point, and anywhere in the map I can figure out how to get back to the beginning. And so with the campus, I've got some relations that talk about that, here's a building and here's a plant. Those are usually separate. So I'm going to use the relationship that this has a location. Campus has a location and it's building one, and it has another location called the plant, the central plant. And that's going to allow me to find the campus and then find all the buildings. And then once I get to a building, I can do several things. I'm going to stick with using has a part, but I have an example up here which I'll walk through to explain. And you can do multiple. I've actually got it both, but I'll show you again. If you sit and think about what I'm doing, the power of these relationships is I can do something where I can say, you know what, I need a hierarchy real quick on what that AHU feeds. And it's done. I just say, hey, go find those relationships. So I'll show you that. But right here, I'm going to say, all right, for this example, this building has a part, it has an AHU, and then I'm going to say the AHU has a bunch of parts called the VAVs. And then I might want to relate back that, hey, a room has a part of the zone, right, as part of that zone. So you can do all kinds of different ways with these relationships, and they don't have to be sequential. They could be, from one device to another device. But what I haven't done is I haven't mapped each one. So I'm trying to keep this clear. So this building has a part to AHU. So the building, I can get to the AHU, I can get to the VAV, I can get to the zone, I can get to the room, and then I can go backwards because all those inverses are already in place, so that if I look at I find that room, I can then figure out what zone, I can figure out what VAV, I can figure out what AHU, I can figure out what building, and I can go back to the plan. That's the power of how these relationships go and are set up. So lots of different ways. Here's one I did for feeding. So I created the relationship for feeding. So this to me is pretty cool because that makes sense. The parts are generic. I think that you could have lots of different parts. So I ended up doing both. I would go and add the rooms as parts, and then I could go in and do all the HVAC equipment to show what feeds. But again, I'll show you how we do this in Niagara, and it'll start to make sense. But this was the best way I could figure out how to visually show this. So the chiller feeds the AHU feeds the zone. If I look at this, and we could say, all right, the zone feeds the VAV 1, 2, and 3. And then, of course, it has all these reverse relationships that say, hey, it is fed by, and it points back to the zone. So it's all kind of got this little map of how I can get to each of the components. And that's what's important with a lot of this ontology. All right. And again, up here, I put this up here just because I could think through as I'm mapping it out that these are the relationships Bricks has. So you'll see has a point, has a part, has a location, feeds, is a submeter, is associated to a certain tag, has tag, and meters, right? So they've kind of boiled it down to these basic relationships. Okay. All right. So now let's flip back to my workbench, and we'll start to take a look at how some of this comes together. So here's the tag dictionary in the service, right? We have services, we have a tag dictionary, we have the tag dictionary, and you'll see that I have a Niagara tag dictionary, I have a haystack tag dictionary, and I have a brick. So those allow me to add these ontologies. Just by me dragging them into the service, there are rules that take effect. There are things that I haven't told to tag, but since they're a base part of the ontology, like this is a unit of what, those all get applied. So just by adding the tag dictionary to the service, there is some benefit. Not a lot, but there's actually a lot of benefit, right? So there are things that it can automatically do, and that's good. Other thing to note here is I can run multiple tag ontologies. This is what's cool about Niagara. So when we started doing this, we had no idea that haystack 4 or brick were coming. We have an architecture that allows us to plug these in. So I've plugged in 2 different ontologies, and they work hand in hand. They'll apply. I can put both sets on a point because I might not know the other end what they want to see. They want to see haystack or they want to see brick, but it doesn't hurt. So that's the tag. I can get that, right? You go to the palette, you search for a brick, I can find it, I add it in, we're good to go. Then it's all in. So now if we take a look at this chiller, so the first example I said is let's just and these relationships are all there. And so what I want to do is I want to show you 2 things. I can look at the relation sheet, and these were all relations I set. And how I did that is I would go and relation mark a point. So if I go up here and I say relation mark the chilled water system, I could then highlight the chiller and the chiller 2, right? And create a relation between the system water and the chiller as being apart, right? And so I can go over there and I can say, let's relate from the chilled water system. So if we're going from, we would go and find a BK has part reference, right? Which were those ones in my group. There it is. So I could apply that to those 2 pieces. And now those have a relationship that this knows that these 2 things are parts. That's how simple it is. So I've been link marking pretty much my career of Niagara. I never did a relation, and now I'm like, oh, actually, relations are pretty good, pretty powerful. So that's as simple. So essentially, all I did was I link marked the chiller, right? Come down here, do a link mark, relation mark, and then I can come down here and highlight. I don't want to duplicate that. Highlight these and say that I want to, and I've already got it, so I'm not gonna tell it to do it, but I would say, all right, link those points from chiller 1. And since I'm doing it down and the from, I would come in here and say that has point. So I'd come down here and do a haystack or a brick has point. Okay, and they're already there. So one of the things that you can do is if you look at the relation sheet, it tells you what I've directly related to with the relation marks. If I spy on that, oops, I spy, whoop, there we go. If I spy on that, it gives me tons of stuff. But what the spy does is it tells me what's being implied from a rule and what's being implied from a relationship. So you'll see is fed by, has a part, right? Those are things that are being applied depending on what I tagged on. Okay, so that kind of shows how I relate these things to this. If we go and look at how I actually looked at naming these things or adding the tags, I'm going to go ahead and highlight all of those. And let's see here. Let's go to let's open this up and say, go into my tag manager. There's the first one. Now what I can do with these is we can drag those in so that I can have them all together. And this is where I use this tag manager to kind of shop for things. So if you look at this pump, I know I've got some cheaters here. So I had a little help from a colleague. And so I put in this direct marker, or I can call it my dummy marker, but this is telling me, hey, that's a chilled water pump, so that when I go and do these demos, I can go add the other ontologies. So the one that I want is this chiller. So I'm working with a chiller. So I'm going to go over and pull down the brick ontology, and then I'm going to just do chill. And it's going to go through and say, all right, these are all the things that have chill in them. And so I looked at that and I said, all right, I'm on a chiller and I can kind of look through here and figure out, is there a chilled water pump? I'll be darned, there is. So I could use that. That might be one. If you notice, if I hover over it, it's telling me everything it's going to imply against that group. So it gives me kind of a preview so I don't have to come down here. Now this window down here gives me the ability to look at what was directly put on that point, as well as what was implied on that point. So I can look at all of these and see that, wow, these were all done by rules, things that I have in the system to automatically do it for me. And what's cool here is I can also see that if I stick, let's say I do this BK command as a direct command, it won't be implied, right? And so I can visually see, because this would override the implied. I can visually see how those are. And then I can just work through this. I can just say, all right, here is a return temp. It's chilled water entering temperature sensor. If I was using, and this, I did this deliberately, that's what the haystack is called. If you look at the brick, well, they just changed entering. So this one says entering chilled water temperature sensor, right? So we'll get stuck on names. The importance is we need to identify easily, quickly, what a point is, what it is, where it came from. And part of the ontology is identifying it. And part of the identifying is of the ontology is what relationships get associated to it. Okay. So this, trust me, this when you're trying to look at a station that already exists and you want to know what was applied, this is a lifesaver. And then you want to know what's implied to it, what was direct added to it and what was implied, because implying is done dynamically. So I can get rid of a couple components if I know it's part of a group and it's done automatically for me, right? So I can't overemphasize this. If you're an old tagger with the tag dialog box, I know habits are hard to break, but this will go a long way. Okay. All right. So now that I have the tags again, what can I do with them? So that's when I started. Well, let's take a look at some hierarchies, right? And so if you look at the first example I did in that mind map, I just want to do has a point, right? And so what you'll do is if I'm going to not look at this one, I'm going to look at this one. All I did is I need to have in my hierarchy a query level as the first one. I have to give it someplace to start. So in this one, I have a tag that I'm going after. And in the next one, I have a name. So what I'm saying is go find this tag, and then we're going to start to build the hierarchy based off of that, what you find there, okay? The next piece is actually, now I'm going to rely on those relations that I added, which was, has a part, is a part of. And that's where it gets pretty cool, because before, if I do it with Niagara, I have to worry about who's the child and I have to pass context into each one of these. This one, I can actually rely on those relations. So what I've done is I said, go find a chiller, because I just want the chiller. And then I said, out of those relations, I can do it either way. I did it inbound. I just want to say, I want to find the chiller and tell me what points are a part of that chiller. That's why I have is part. I could do it in the outbound, which has part, but I often get those confused. So however you want to associate that, you can do it, but you can do it both ways. And then if we look at that hierarchy, you'll see that, boom, what you'll see is I did not, in my actual points here, include the actual simulation block. So it's not part, it doesn't have a relation that points back up to that chiller. So it won't show it. So that to me was, okay, I can remember this. And where I also want to take this is as you're tagging with these ontologies, build out how you want these to work. And then this is your proof that you're doing it correctly. Because as they fill out live, gives you, oh, I've tagged that piece of equipment correctly because these points are all up showing here and so forth. So I'll show you another level where I try to do it in folders going down multiple levels. So I have a campus, I have a plant, I have a building, I have a chiller in the plant, I have an AHU and a zone. So if we look at that hierarchy, it's a little different. I first have to find my starting point, campus. So I'm relying on a tag that Niagara puts on everything. So I said, go find the name that is campus. And then I have a relation that says, okay, I know the campus has buildings, so I'm going to have to go off of it has a location. So here I was thinking from the campus down to the building. So I use the outbound and I say has the brick location relation. And then it can pull those up. I'm going to do another one that says, hey, I only want one level here. I don't want it to go down into the next location, right? Because I only have one level. So I don't have a repeating relation. But here I say, all right, I want you to go find anything that you find here that has a part. And I want you to do it 5 levels down. And that's all I'm asking it to do. Find this, start here, find what locations are in the campus, and then go find things that have parts and list them out. And if they have a part, I want its parts. Okay. And if you look at this hierarchy, this is my hierarchy when it runs. So I'm going to just refresh that, say test. It found the campus because that's the name. It's now going down to the locations. So it's going to say, hey, go find this location. It found 2 at that level. So it listed those. If I have a master campus and other campuses, like a city or campuses, I could relate and actually tell this to do multiple levels down so it can find those. But get the picture of how these relations are work. I can go into the building. I said, all right, out of that building, remember I said all those parts I marked? It found that these are all the parts there. It went and said, okay, I found an AHU. Now I need to go get its parts. So it found that AHU has a zone. It asks for the zone and says, all right, what are your parts? And then it actually builds out that. So I didn't have to do any context things. I just kind of understood how the relations work and how they interlink. And then boom, I can build a hierarchy based on those relations. So that's out of all that, that's what I wanted to show you how easy it is. And now kind of, I'm going to go back to the slides to kind of show you what, where's my PowerPoint, what the tag rules can do for you. All right. So that's kind of how we'll end this. We did the demo. And this is kind of like a public service announcement. I can't talk tags without talking rules. I know some of you are probably rolling your eyes because this is a little harder to do, but the benefit of this is much more satisfying when it works, because if I have to go edit something, I can just edit the rule and it fixes it. So half the time we have these points that have all this crazy stuff in it because at one point in time we limited the name of the point and we had to figure out how to do that. So I'm going to use these tag rules to help me figure, or these rules to help me figure out what's in that name so that I could apply the points that I want. So space temperature might be what I'm looking for, or it's the high level concept, but it might be called space temp, space TMP, uppercase characters, you know, all that, space temperature. If I'm an enterprise, I probably have different variations of this. I can make one rule accommodate them all across all these different installs. So rules can be very powerful. what a rule looks like is you just kind of give it context. I'm using folders and a control point in the demo. Usually that will map to like a backnet of a piece of device. I'm looking for damper position or damper POS. You're going to see that I'm going to show you some pseudocode. You can get fancy with ignore case and do and ors and nots. And then what I want to do is when the rule tests positive that this should be engaged, it's going to apply these tags. They could be brick tags, they can be Niagara tags, however you want, you can apply them. But I can't overemphasize rules can save you, they're a little more time up front, but they can save you a lot of time downstream. So here's my pseudocode just to kind of throw the stuff on and how it gets organized. I want to ignore case, so I have to know this regex thing. And there's actually, I didn't know this, but there's documentation in Niagara that talks about that. It's extremely powerful, more powerful than I can actually comprehend and do myself. The next thing I need to know is wildcards. And we have a way, a dot star, dot star. You can put two things and anything before and anything after, it's going to ignore. So that's going to be important. I know I'm going after the tag name. I need to look and have a way of representing that in the rule, which is going to be like, it's an operator. And the things I'm looking for are those characters. Doesn't matter what they are. I did room temp so that we can easily understand it. So when I built this out, I'm going to say that that name is like, I don't care about the case, but it has those letters, room temp, ROOMTEMP, somewhere in the middle or in the beginning or the end. I don't care. It's somewhere in that name. That's what it looks like when I apply it to the tag rule. So not too much different, but I built out the blocks because I needed help when I started to teach this. Do it this way, map it, and then there's the output. And then that will be what's in the rule. So then I said, okay, I got challenged. Somebody goes, well, what happens if I've got some things where it could have one piece or another part, right? And so actually this whole thing accommodates that. Ignore the case, need the wildcards. I'm going to go after the name, but now I'm going to add in some operators like and or. I'm going to look for the different set of characters. I'm going to look for damper, set point, and command, SPT and CMD. So those are different patterns, but don't worry, I can do it. So I had filtered out his name is like, ignore the case, somewhere in it, it has damper, but it also has, with an and, it also has to have the next set, which is I need it to have set point in it or that CMD. So I can now have something that has damper, and if I want to do a query or search for anything that has a set point and a command, I'll get both, even though it has damper. So it's a different name, but it's looking for those pieces parts. And then again, the bottom line is how I'm going to apply it in the actual tag rule. Notice the parentheses. Just like math, if you have doubt on how those things are operating and working in what order, parenthesize the heck out of it and you're good to go. So that's how I did that. That's one of my little tips and tricks. All right, last thing, name. I'm going to use, it doesn't have either one of those. So I just want to find damper with no set point or temperature. You can do the same thing. Okay, so hopefully I've conveyed how rewarding tags can be. A little cheesy, but you get the point, right? There's tools, our ability to identify, our ability to use the tools, and now I can actually reap the benefits of what I just did, and that is I can do hierarchies easy, I can bring searches to life, I can enable analytics because you need tags for that. I can future-proof that station so that it can connect to the cloud easily because the model's there. One thing I will note is that a lot of times when cloud vendors come in and put gateways in, they own the model. They spend the money, you pay for it, and they tag that data. They don't give you that data back if you change providers. Having it inside of Niagara, part of the tag dictionary, means that we can create a model where the customer owns that, and then they can offload that like in Niagara Cloud and say, hey, third party, use the model that we have there. It's already tagged and ready to go. So those are future proofing those types of connectivity to your customer base. This is being recorded. Oh, these are on auto. Recorded, or somebody's telling me to move ahead. There are Tridium talks. This is being recorded. This is how you find it. There's tips and tricks. And then there's research documents, or not research documents, a whole bunch of documents on all of the stuff that we have on our access. If you haven't realized this, Niagara community has a docs at niagara.com. And then we also have documents where you can go pull up, what's Niagara 4.14. So there's a resource center that has those types of things, PDFs, the PowerPoints and things of that nature. And then Docs has all of the components that we have out there. So all of Niagara documentation has been in two places inside of Niagara, as well as in the web. And the web we can augment with media. So I went a little long, but I get a little excited on these things. So I think we're going to open it up for Q&A. So, Tim.
Yeah, so there's a couple of questions here asking to kind of describe the differences between haystack and brick, and maybe why would someone choose one over the other. I guess my response to that is it's nothing. There's nothing in Niagara that will lead you to choose one or the other. It's more which are you familiar with? Maybe which is might be specified by the job you're working on. I would suggest reading the documentation of each and using that as a basis for determining which one to use.
Yeah, that is a great question. It's a question I asked myself. And again, like Tim said, it comes down to the customer. If the customer doesn't know, but they're going to connect to some third party, you can say, let's go haystack 4. I would not do haystack anymore. I would do haystack 4 or brick. Brick was invented in the academia space to handle a way of finding out a point and how it feeds to it. Both do it. So haystack does site refs, and we automatically do that. It requires a tag to do in place. Brick right now is a little more manual because we don't have rules in place to understand how those will do it, but they both do. In fact, when you look at reviews of brick and haystack, and there are a lot out there, everybody comes to the conclusion that they're very similar. So we're Tridium, we're going to do any of those, understand what your customer is, what the industry is doing, and you can figure out which one you go to. But I would definitely say I would move to the 4th generation of haystack, because those groups, how I shopped, is a powerful way of doing it. It helped me out. Otherwise, I have to think, oh, I have to add all those tags. So it completely changed the way I looked at it.
So another question, how can we get tags out of Niagara?
That is a good question. And I don't have an answer for that. Do you, Tim?
Well, I know that we have some of our cloud customers are using the cloud connector to export tagged data out of a station or a supervisor.
Yes. So now I get the context. So like if you look at Niagara Cloud Suite, we have Niagara Data Services. It actually has a component that takes the entire supervisor or station model and puts it up into the cloud so that an API can query it. It can pull out essentially what this point is, how it's relating to the points above it, all of its associated tags, and all of its associated relationships. So if you're looking for a way of pulling that data and looking at how that model's built out, part of NDS is that capability. So I could hand a third party and say, here's the model. It includes all the tags, how all those relate. They can use the API to understand how the hierarchies are automatically there and what relates to each other. And then they can use that model to build their interface. And then the rest of it is, calling on the points and figuring out, oh, we need to know what was coming upstream and working through those relationships programmatically. These ontologies are all about how other systems can read through that data. So putting the tags and putting it into a flat file list doesn't help anything because it needs to know how things are interconnected, and that's where these models come in. So when you look at an ontology for brick, an ontology for haystack, they model everything together so that you understand all those relationships. And what we had to do for Niagara Cloud Suite is we had to actually have the model in the cloud so that those third parties can actually call those models to understand how that all comes together.
So a couple of other questions. Can you use both haystack and brick at the same time on the same job?
Absolutely.
And another question is ASHRAE 223P going to be supported?
Do you have an answer on that one?
I do not have an answer. I know that it is certainly something we are participating in, defining, helping to define what that spec is going to be. And I expect that when it becomes more fleshed out, it's something that we will add support for. But I don't think that no hard decisions have been made at this point.
Yeah. Do we know if the spec is ratified, finished? Is it still work in progress?
I do not know.
I'll take that as an action, as a follow-up in the paper Q&A that we post underneath the video. I'll take a follow-up to figure out where we sit on that.
So here's one. Is there any efficiency consideration to using the logic condition components from the tag dictionary palette versus placing all conditions in a single Boolean filter and equal statement? I'm wondering if that has to do with hierarchies. I'm not sure. Maybe it's a question of just the efficiency of the equal itself. I guess my answer would be there can be more efficient ways to set up a system than others. It's hard to give hard rules for those efficiencies just because tagging and equal are both very flexible, and trying to figure out the most efficient way is not an exact science.
Yeah, and there's trade-offs, right? If I add a direct tag to a point, it takes a slot, right? Which takes more memory and heap. If I have a rule, that can also be, you have to watch when you create rules that they fail fast. And then you have to make sure that in your rules, if you are looking for implied tags, it definitely has a fail fast mechanism. So when I create a rule, I'm not evaluating the entire station. I'm looking at, all right, I need to look at this backnet device, and then I need to look at how those points are related to. So it won't look at everything. It will look at this particular device when it's creating those rules. So the trade-off in a rule is it's automatic and it's implied on demand. So it's not something it has to index. It's just as I walk through those things, those implied tags are automatically done. But it's a trade-off, right? I have to look at, do I have a system enough memory and heap that I want to do direct tags? Direct tags, if you use groups, are easier to maintain, or I would say you can change them if the standard changes, they'll change with the new imported JSON. rules are much easier to fix. So I always lean towards the rules, because if I have a couple 100,000 points and I direct tag them, and I've done this, I had to learn how to undo that. And now I'm using a different set of tools because I made a mistake that I didn't want that direct tag. In a rule, if that direct implied tag is applied to those 100,000 points and I didn't want it, I edit the rule and then done. I don't have to undo anything. The rule is done dynamically and it will take effect. So you're correct, and you have to weigh the pluses and minuses of putting a direct tag versus an implied tag, but you have to look at what you're trying to do and how many points you're trying to set through
So
that rule.
there's an associated question. Is there any way to create custom rules to apply tags from a standard dictionary without having to manually copy the tags from the standard dictionary into your custom dictionary? Yes, there is. So in Niagara 4.14, yeah. So we went through an example here, and in Niagara 4.14, we have added support for a JSON, the contents of the tag dictionary to be exported and imported using a JSON structure. So it's actually possible to export, or if you look into the Brick module itself, the data for the dictionary is contained in a JSON file inside that module, the Brick RT module. And you can take that JSON and then add your own rules to it and re-import that into your dictionary. So you can edit those externally with any sort of text editor or JSON editor you want to add in any custom rules that you want to be able to apply. Here's a question: is this designed for a supervisor due to the overhead of relationships? In other words, would a lot of tags overwhelm a JACE?
So usually those, if I'm trying to do campuses and things of that nature, that's in a soup. So what's nice is that if you create your own, so to answer that previous question, if you looked at my tag rule, I had my own tag database, but my rules applied haystack or brick tags, right? I don't want to reinvent that ontology, but I wanted my rules to run based on my naming conventions. So I create a separate tag dictionary. It has the rules that go through all the different naming conventions that I have and applies the appropriate tags. That is something that I can copy to a JACE and I can copy to a supervisor, and it will work the exact same way. In fact, I can template that and deploy the template on the JACE and deploy that template onto the supervisor. Then that way I can use the templating service to keep that up to date. You have to look at how much data is coming in and where you need it. If I need those up at the soup, do I need them in the JACE? Not necessarily. So if they're all in rules, I just don't have those rules in the JACE because they're going to be applied at the soup because I've exported all those points. So you have to kind of look at what you're trying to do and what you're trying to model. Niagara Data Services works in both. So we have customers that have giant soups that they want to model. And then we have customers that just have a JACE or a couple JACEs and they need it to run on the JACE. So.
Okay. One other question: is there any certification training that gets into building ontologies in depth as part of the curriculum? Haystack or Brick or both?
That's a great question. And we'll take that feedback back to our training folks. Good question. All right. I think we can wrap it up. All the questions that we haven't answered, we will put together a Q&A document that will be posted under the video. And I thank you for your time. We ran a little long. Sorry about that. But it's a deep topic. And thank you for attending the Tridium Talk. Thank you for your time.